Righto, Year 12, I will now have a go at some of these questions from 2 to 12. Remember, don't spend too much time on these ones, particularly if they're an area one. I told you not to do 9 and 10. You can have a go at them, but don't worry too much. They don't ask you to do areas by substitution. They just ask you to do integration by substitution. So I'm going to pick up from question 4, and we'll do the even ones. So 4, because that'll give us an area, a volume, that nice T1, and then 10. So here we go with question 4. And I've got to find the area between the curve and 1 and 0. Now I probably should draw this, but when I look at this question, that's going to give me an x to the 7, and when x is 0, I'm going to get 0. When x is 1, I'm going to get a negative. But remember, it doesn't matter. Oh, yeah, I'm going to get a negative area. So when I do this, I'm going to have to look at this. So I will have to draw this. So we're pretty lucky in that we know certain things. Well, we know that that's a triple root. So when x is 0, I get a triple root. So at this point here, at a triple root, which I know is a point of inflection, I know this is a positive x to the 7th. So this curve will look something, could look like that. All right, 1, 2, 3, 4, 5, 6. Could have 6, or could have none. It could look like that. It could look like that. Could have looked like any version of this. And x to the 4 equals minus 2 gives us x to the 4 equals 2. So we're going to get root 2 and negative root 2. So this curve, possibly, that's a point of inflection. It could do some other things, but between 0 and root 2, remember 1 is less than root 2, so 1's here. So I'm going to quickly go to Desmos and double check this. This is why they tend not to ask these questions. So what do we want? Let's get rid of this and go y equals x to the power of 3 brackets x to the power of 4 minus 2. Out of there, bracket x minus x to the power of 4 minus 2. And there we go. It did look similar to what I thought it did, although there was another lump there. What did I draw? Yeah. So the area we're going to find, this area here, is going to be negative. All right, this area is going to be negative. We have to take that into account. So between 1 and 0, the area, let's erase this. The area equals, well, we'll take the absolute value, because you know it's negative, between 1 and 0. And what's our equation? X cubed x to the 4 minus 2. X cubed x to the 4 minus 2 dx. Now, there are two reasons why they won't ask you this sort of question in HSC. One, they will give you what you've got to let u equal. All right. The other one is they tend not to ask area questions because to ask them, you need to have these higher powers of x, and it would take too many marks, or they'd allocate too many marks to this question to put it in here. They possibly could. It'd be a pretty nasty test that did that. So I'm going to go equals over there. So I'm going to let u equal x to the 4 minus 2. And therefore, du dx equals 4x cubed. And when I'm going to change the parameters, x equals 1, u equals 1 to the 4 minus 2, which is negative 1. When x equals 0, u equals 0 minus 2, which is minus 2. For those people who are writing du in terms of x, so du equals 4x cubed dx, and those people who are doing this method, du on 4x cubed equals dx. Okay, so this is going to equal, so I've changed my parameters, minus 1 to minus 2. I've now got x to the 4 minus 2. I'm going to move this x cubed to the other side, dx, and now I'm going to put a 4 in. I'm going to take a 4 out. I find that much easier, but if you want to just substitute this whole thing in, that's okay too. So now I've got a quarter between minus 1 and minus 2. That's strictly not correct because I changed the parameters without changing to u and du. So that line is a little bit incorrect. Let's not have that. I shouldn't change parameters until I change the integration with u in there. So now I've got that. Now I can go, well, that's going to be u, and 4x cubed dx, well, that's du. So u du, and now my parameters make sense. So it equals, forgot my absolute values. I would have realised that when I got to the end, a quarter. So add 1 to the power, u to the 2 over 2 between minus 1 and minus 2, which gives me a quarter minus 1 squared on 2 minus 2 squared on 2, absolute value, which gives me a quarter. I'm going to get a half minus 4 on 2, which is 2, which gives me a quarter times negative 3 on 2, which is negative 3 on 8, which is, this is right, absolute value is 3 on 8 units squared, and it is right. I've got the answers open on the other computer. Whew. There we go. Righto. So, sorry, keeps flipping between things. There you go. That was pretty difficult. All right, let's have a look at question 6. Find the volume. Find the volume when it's rotated about the x-axis. Well, again, they won't give you this because it's too difficult because you've got to know the sketch. Anyway, let's have a go. Y equals x cubed minus 3 all squared. Y equals x cubed minus 3 all squared. Well, that straight away I know that's a double root. So that's a turning point. And I know that this is going to be x to the 6 times it's going to be another x to the 7. It's going to be another one that looks like that somehow. And that's why they're not going to ask you this, because you have to sketch it. So I know I've got a root at 0. And I know x cubed minus 3, which is going to be the cube root of 3, is going to be a turning point. So somewhere here, the cube root of 3 is a turning point. I know it's coming down there. It could do anything between there. It could go up and come down and do that and then get, oh no, I know there are no other roots, so it can't do that. That's a bit silly. There are no other roots. So I reckon it's going to do, what did I say that was? The double root's a turning point. It's going to do something like that. It could do some other crazy stuff either side, but I reckon essentially that's what it's going to do. And I'm going to rotate this volume between 0 and 1. Now I know that the cube root of 3 is more than 1. So I know that 1's here somewhere. And this volume is going to be rotated. Now it doesn't matter with volume, because in the end I square it, because we're using pi r squared for our cylinder, because we rotate, we get volumes of cylinders. So I'm not that fussed about it anyway if it was negative. The only problem would be if it wouldn't even matter if part of it was negative and part of it was positive. All right, let's have a look at Desmos to see what it is anyway, see how close we were. X cubed minus 3 all squared. So get in here. X, delete that. X to the power of 3 minus 3 to the power of 2. And there we go. There, it looks like that. So the better you get at curve sketching, the better you tend to get. So, yeah, look at that, we got this positive area to sketch or to rotate. All right, so let's set it up. So our volume equals pi between 1 and 0. Now we need y squared. So we need all that squared. That's why it's good that they wrote it in factorized form. So y squared equals x squared, x cubed minus 3 to the 4. If I square all that because of multiplied terms, I'll just square each term. Whew. So we've got x squared, x cubed minus 3 to the 4 dx. Goodness me. Righto. So what are we going to let u equal? Well, obviously what's inside that parenthesis. So let u equal x cubed minus 3. So du dx equals 3x squared. Therefore du equals 3x squared dx, which is what I go with. But for the people who are doing it, they're going to write du on 3x squared equals dx, and they're going to sub that in. Okay, what else do we need to do? We need to find out what u equals when x equals 1 and 0. So when x equals 1, u equals 1 cubed minus 3, which equals negative 2. And when x equals 0, we get u equals 0 minus 3, which is minus 3. So over here, I get pi outside. I'm going to do this all in one go. Oh no, I won't. I'll keep it 1 and 0 in case you're having trouble. I'm going to swap that x cubed minus 3 to the 4. I'm going to put my x squared there, but I'm going to leave a gap in front of it, dx. Now it's almost the same. I've got to make it look the same as that. So I'm going to put a 3 in and take a 3 out, and then I can rewrite it. So I've got pi on 3. Now I can change my values because I'm going to do it all in u. So I've got minus 2 to minus 3. I've got u to the 4 du, because look at that, that's du. All right, so here we go. equals pi on 3. Add 1 to the power u to the 5 on 5. Between minus 2 and minus 3. Which is going to give me pi on 3. I'm going to get 2, negative 2 to the 5 on 5 minus negative 3 to the 5 on 5. Oh, this is going to be ugly. Which is going to give me pi on 3. I know my 2 to the 5, that's minus 32 on 5. I don't know what my 3 to the 5 is. I know 3 to the 4 is 81, so 3 to the power of 5 is 243 minus 243 on 5 plus 32 is, minus 32, 211, which gives me pi on 3 times 211 on 5, which gives me 211 pi on 15 units cubed, which is the right answer. Hooray! Whew. All right, one more. I did say I was going to do all the evens, but I'm going to stop at 8. Let's see what 8 is. 8 is T1. I wouldn't worry about 9 and 10. If you get up to 8, I'd go and do the HSE questions that I put out for you. So 8's nice and easy. It's an integral of t on root t plus 1. Sounds interesting because I'm pretty sure that's some of our t formula that we might have used. I don't know. Maybe it's our tan theta equals t on 2. I don't think so, though. 3 and 0. See? Oh, get out of there. Question 8. And we got 3, 0, t on, well, it's not the same because it's not t squared plus 1, it's just t plus 1 dt. Let's let u equal t plus 1, therefore du dt equals 1, therefore du equals dt. That's nice and easy. I also know if I minus that 1 that t will equal u minus 1, and when t equals 3, u equals 3 plus 1 is 4. When t equals 0, u equals 0 plus 1, which equals 1. So let's all put all this in now. So we've got equals. All right. I'm going to change the parameters straight away from 4 to 1. I'm going to substitute that in for t. So I get out of there. U minus 1 on top of. Down here, I'm going to substitute that for u. So u to the half. U to the half to down there. And it's all with du. Okay. I'm going to play with this a bit more because I've got that u on the bottom. So u minus 1 times u to the half du, which is 4 and 1. Now here I'm just going to do this expansion, u times u there, and one of those. So I'm going to get u to the 1 times u to the half is u to the 3 on 2, minus u to the half, because 1 times u to the half is 1 du. Now I can integrate. Add 1 to the power, that's u to the 5 on 2. Divide by 5 on 2 is multiplying by the reciprocal, so 2/5. Minus, add 1 there, so you get u to the 3 on 2. Divide by 3 on 2 is multiplied by 2/3, between 4 and 1. Now, two times 4 to the 5 on 2 over 5 minus 2 times 4 to the 5 on 2 over 3 minus 2 times 1, because 1 to the power of anything itself, on 5 minus 2 times 1 on 3. Whew. Now luckily I know the square root of 4 is 2, and 2 to the 5 is 32, and 2 times 32 is 64. 64 on 5. Geez, I hope this is right. I hope I don't make a mistake without the calculator. Do the same again here. Square root of 4 is 2. 2 cubed is 8. 2 times 8 is 16. I get 16 on 3. Here I've got 2 fifths minus 3 fifths and minus 2 thirds. I'm not going to try this in my head. I'm going to do this on a calculator. I'm sorry. So 64 on 5 minus 16 on 3 gives me 112 on 15. And over here I'm going to get 6 on 15 minus 10 on 15. Is that right? 6 on 15 minus 10 on 15. It's going to give me minus 4 on 15. Just let me go that again. 6 on 15. Oh, you idiot. It's going to give you minus 6. Minus 6. 6 on 15. No, I was right. Minus 4. I'm going to my calculator. That's ridiculous. 2 on 5 minus 3. 2 over 3. 4 on 15. Come on. I was right. Which gives me 216 on 15 units. Now, that's 2 2/3 for question 8. So I've done something wrong here. I don't know if I should have done that in my head. I'm going to double check that. Oh, yeah. So 2 times 4 to the power of 5 on 2, 64. And if I go back and I just change to 3 on 2, 16. 64 divided by 5 minus 16 divided by 3. Well, 8 is giving me 2 2/3 and I'm getting a completely different answer. And I may have done it wrong. Right, well, I'm going to, let me see. Let's add 1 to the power, 3 on 2, minus u to the half, add 1 to that, it's going to be 5 on 2, multiplied by the reciprocal, 2 on 5, add 1 to that, it's going to be 3 on 2, multiplied by the reciprocal, it's going to be 2/3. I'm going to stop it here. I'm going to see if I can go back and find my mistake. You keep going, and good luck with them.